Welcome to module 5 of object oriented analysis and design. Here we will primarily talk about what should be the broad approach of designing object oriented systems. Before I get into the specific objectives, let us just quickly recap the major points that we have discussed so far in the course. Initially, we talked about why software projects failed and identified that software development, software projects are inherently complex, and there are 4 primary elements of complexity coming from the problem domain, the difficulty of development processes, managing development processes, the flexibility and the problems due to the discrete system structure of the software systems. Then we tried to study different complex systems, natural, man-made, social and so on, to understand if there are commonality between different complex systems, and we identified 5 different attributes for complex systems, starting from the hierarchic structure, the primitive relative primitives or the basic building blocks, separation of concerns, common patterns and stable intermediate form. Equipped with this, we then discussed in the last module about how we can handle complexity, and we observed that the complexity of the design development process of a complex software system can be divided in terms of organized approach, which is primarily driven by a canonical form comprising the object and class hierarchy, the 2 orthogonal dimensions of representation in a complex system, and the 5 basic attributes of the complex systems. At the same time, there is quite a bit of disorganized complexity arising out of the limited human capacity to handle limited number of information chunks at a given point of time. So, equipped with all this, in the current module, we would like to discuss about some basic strategies for design of complex systems. We will define what is our understanding of a design and that of a model. The outline will be primarily about the part to approach the whole design process in terms of the roles of decomposition, abstraction and hierarchy. So, we start with analyzing the role of decomposition. As to we have seen that there is a decomposition structure, there is a possible decomposition of the system in several instances, we have seen that. Now, we want to really investigate that given a system, how do we go about doing this decomposition, and we note that there are primarily 2 approaches that have emerged over the last 50-60 years that software development has been practiced. First is the algorithmic decomposition approach, and the second is the object oriented decomposition approach. We will take a look into each one of them, and then towards the end kind of compare them to see what has an advantage over the other. So, algorithmic decomposition, this is certainly the most fundamental, oldest. This has been around for a very long period of time, and it is primarily a top down structured approach that given a problem we can divide it into a number of 2 or more, usually a number of different sub problems which are simpler in nature and whose solutions together can solve the whole problem. In very specific terms, we have studied this kind of approach under divide conquer kind of algorithmic paradigms, while we did binary search and merge sort and things like that. So, in general, what we will look at algorithmic decomposition as is to decompose the problem in terms of key processing steps. So, the main thing here to note in algorithmic decomposition is you decompose the problem in terms of key processing steps. So, what is inherent of algorithmic decomposition is you identify processing steps, then identify the key processing steps and try to decompose the whole problem in terms of those. So, here is an example. This example is from our textbook. So, here the problem is to update a file. So, this is the top level problem that we want to actually address, solve. So, for doing that, certainly a file will have some master area where the information about the file is written, then the format of the file, then there are several matching and update operations that need to be done. If I am updating the file, the new master area need to be put up and so on. So, based on that, the update file, this whole task of update file is divided in terms of a number of subtasks or sub goals which are given in this layer. So, this is one level of decomposition where this is the first level in which the tasks are decomposed. Then if we concentrate on any specific of these tasks, say get master area, if this task has to be accomplished, then it can be done in terms of doing two other subtasks of get the OK master and to expand. It really does not matter that much if you do not specifically understand every detail of what these subtasks are in this particular case, because what we are trying to explain is a broad idea of how decomposition can be done. So, we can see that over this whole tree of this is the root level and 2, 3, 4 and 5 levels, we try to solve this problem by algorithmic decomposition. And whenever we reach a level, say get update card, add checksum, tasks which do not have other subtasks, that would mean that that is at a level where it can be directly implemented in terms of an algorithm, possibly in terms of a specific function. So, this is one way to actually try to decompose the problem and start solving it, and this particular kind of a chart is known as a structure chart, because it shows how the tasks are structured, and in this particular case this chart was generated from an expert system tool. So, that is interesting, because that means that quite a bit of automation can be done on this. The input was a data flow diagram. You may not right now be aware of what data flow diagrams are. Over the course of this our discussions, we will also talk about data flow diagrams, but an expert system tool can take the data flow diagram, which basically say how data is going through the system, and make this structure chart of algorithmic decomposition. So, in this it has divided the problem into very specific different steps, like get formatted update as in here, or add checksum as in here. Some of them are primitive tasks and some are still composite tasks which need further subdivision. So, this is the basic approach of algorithmic decomposition. You look at the whole task, you are basically going by the processing logic, try to divide that into subtasks, take every subtask and try to divide that further into smaller subtasks till you get to primitive tasks that can be directly solved. In contrast, we can do an object oriented decomposition. In object oriented decomposition, we do not look at the specific tasks. Rather, we try to decompose the system according to the key abstractions of the problem domain. That is, we take a look into directly the vocabulary of the problem domain. What is the problem domain talking about? Updating file means what are the basic concepts, what are the basic entities, the basic agents that the problem is talking about. And we will try to decompose the system in terms of those key concepts, key ideas, which we refer to here as key abstractions, and then try to model and solve the problem. So, it is quite different from the way the algorithmic approach will go. So, in here for the same problem of update representation, Here we basically divide the problem into number of different agents. One we say is a master file. Naturally, that needs to keep track of what is happening to the other files. This is a file of updates. This is update to card, the checksum and so on. Each one of them is a key concept, is a key abstraction in the whole problem domain. And if you look into the arrows, these arrows mean that file of updates is an object which support this operation. That is, master file can invoke get formatted update on this file of updates object, or master file can invoke get, put or create operations on the master record object. So, the view has become completely different. There is no specific get formatted update functionality and the breakdown of that, rather that's get distributed in terms of a number of different objects, and those objects are objects like these are identified directly from the problem domain, where we find that these are the terms, these are the vocabulary that the problem domain is dealing with. So, this object oriented decomposition approach is quite distinct compared to the algorithmic decomposition approach. The first thing is we view the whole world as a set of autonomous agents. This statement is a simple short statement, but this is a very strong statement about object oriented decomposition, in fact about object oriented analysis and design. That is, we think of that this whole system as if it is a collection of certain autonomous agents. Autonomous means active entities which can behave on their own. Kind of if we close our eyes and try to think about the system as if there are a number of agents floating around in the universe, and each one of them can independently act based on what its behavior is, based on what it is requested by others to do, and based on what it needs to request others to do. So, we will take a look into those aspects, but just remember this is the basic view, that is a number of autonomous agents collaborate, work together to perform some high level behavior. So, let us say how does our original functionality of get formatted update, how does that happen? This is now removed as an algorithm. So, we do not have any specific algorithm on this. It now has become an operation with the object file of updates. If you are unclear about this, let us just one step go back, and if you see here, now this file of updates, this object has this as a method, this as a request that master file can put to this particular object. So, this is the difference, this is the change in structure that is happening between the algorithmic and the object oriented decomposition. So, that is why we are saying that now this get formatted update becomes an operation associated with this object. Similarly, when we call this get formatted object on the file of updates, this is an object, the operation creates another object, update to card. So, it will in turn create an object which is update to card. I will just show you in that diagram. Let us say here as this is operation is invoked on this object, this in turn invokes a get reformat which generates a new update to card object. So, the way the whole thing is modeled, the way the whole thing is now being decomposed and represented are very different, and all are in terms of this concept of autonomous agents, which are now this particular file of update object, update to card object, these are collaborating to actually achieve the functionality that earlier we had represented in terms of a complete task subtask decomposition for algorithmic approach. So, every object has its own unique behavior and each one models something in the real world. Now, this is not easy to see at this stage. Maybe you may be feeling confused. As we do more and more examples, this will become clear, but keep this in mind that these autonomous agents are not arbitrary. Every autonomous agent must correspond to some basic concept, some basic unique behavior in the real world, in the problem domain that you have. Only then your design would become really effective. So, an object is simply a tangible entity that exhibits some well defined behavior, tangible in the sense that in the real world it has some proper existence, and it can do things that we ask them to perform, and they do this by, this is interesting, and they do this by sending them messages. That is, the main thing that the objects can do, they can exist on their own as autonomous agents, they can perform some tasks which we say are operations, and they can send some information, some message to other objects to perform some tasks. This is the whole view, and since this whole view is based on the objects, rather the autonomous agents, and not on the specific algorithms that they perform, we call this an object oriented decomposition. So, let us take a look at then, if this is how we think about doing our decomposition, then how is our problem getting solved? If I have done an algorithmic decomposition, then we all know how the problem will get solved. We all know what is the computing model. What is a computing model? Algorithms correspond to basically functions in some high level language, as you can perceive, and we always know that functions can be executed in the CPU grossly in a von Neumann model. Any algorithm can be executed, or if I talk in abstract terms, then using Turing machine the algorithms can be executed. So, we know that it always have data in the memory, it will have instructions or operations or primitive tasks that it can do in terms of the instructions. It will take the data, perform the instruction and put that data back. That is a basic computing model. In an object based system, the computing basic idea of the computing model itself gets very different, and this is because of two reasons. One reason is that when we are talking about object oriented decomposition, which has resulted, or object oriented design has resulted after lot of maturity of software system design. This is not as primitive as the algorithmic decomposition or algorithm based design of systems. So, by the time we started doing object oriented design and object oriented decomposition, we are equipped with a variety of different computing models. Some of them are purely von Neumann in nature, some of them follow certain languages like Fortran, accept languages like Fortran, Pascal, C, C++ and so on, while others could have multiple processors, they could have different shared memory models, they could do some remote procedure execution and so on. A variety of different computing models over the years have emerged. So, the other aspect of object oriented decomposition is also to keep in mind that as I decompose, what is my computing model? And when I decompose, I want to make minimum assumption, or rather I should say minimal assumption about my computing model. I do not want to, I yet do not know what will be the best way to design and implement this system. So, I do not want to assume that I will run it on a Pentium 3 or I will implement it on a DEC alpha processor with 8 cores and so on. I do not want to make such assumptions. So, I make a simple assumption that it is a client server computing model, which say that I have a collection of autonomous agents, the objects. So, object 1, object 2, object 3, object 4 and so on. and on every object I have some possible operations that I can do. So, this is known as the services. These operations are known as the services offered by the respective objects. So, these are the different services that the objects offer. Now, the way it works is any object can send a message to another object. This object, say if we just turn over to blue, this object can send a message to this object saying that I want to use your method or your operation to 1. So, it kind of sends a message like I want to go to O2 and use F21 and so on. These are the data on which this F21 should be used and so on. So, what happens is when O2 receives that, whatever is this method operation, that method operation will start being performed. And when that is being performed, O2 may need that I would need the help of the operation F12 of object O1. So, it sends a message to object O1 with F12 with associated data. And while all these are happening simultaneously, on a separate note, O4 may have sent another request to O2 for doing some operation F22, and all these can keep on happening at their own sweet pace, at their own sweet independence, and this is what is known as a client server model. Why this is anybody who requests, for example, here if O3 was requesting. So, we will say here is a client, and who was being requested? O2, this is called the server. So, as if as you say that we say and ask for services for the human vendors, it is a similar concept. The client will ask for a service from an object. Now, there is no specific object as a client, nor a specific object as a server. It depends on who is in that what mode. Whenever a message request is sent, the sender who is requesting for the service is a client, and the receiver who will provide the service is a server. And this happens in a completely distributed manner. So, you can say understand that as long as you can have some computing system, some realizable system, some implementable system where you can have these autonomous agents or objects, and you have some mechanism to pass messages, send messages, you will be able to implement a client server model. So, in very concrete terms, if we talk about say C++, then basically objects are instances of classes, and the sending of messages is nothing other than actually invoking or calling method functions. So, that is the basic model. I just a little bit discussed it, so that as we go forward and keep on doing more and more of how the complex systems are designed, we will have this particular model in the background. So, we have discussed the basic of algorithmic design, algorithmic decomposition, and the object oriented decomposition, and we will next take a look into how do they compare based on their historical evolution.